Hello students, I am Professor Gadakaryas from Sundarabai Manik Adsul Polytechnic, Chas, Ahmednagar. Today we are going to learn the problems on cantilever beam. Let's start the session. Example: a cantilever is loaded as shown in figure. Draw SFD and BMD. In this example, cantilever beam is given with the point load and UDL. This figure is given, a loaded diagram is given in the problem. Student, you have to understood which type of load is given in the cantilever. First learn. In that cantilever beam, point load is given at the front, another point load is given at the point C, and then next two UDL is given in between the span C and D and A and B. Okay, I already told you, if UDL is there, then you have to convert that UDL into the equivalent point load. And all of you know the concept, how to convert the UDL into the point load. How? UDL is what? 20 kilonewton per meter. This 20 kilonewton per meter into the length of that UDL, and that equivalent point load is acting at a mid span of that UDL. Okay. So convert this 20 into 3, 60, and that is act in a mid span. Total span is 3. Mid span is what? 1.5 meter. 1.5 meter, 1.5 meter. This is the mid span of that UDL. And point load is 20 into the total length of span is 3. 20 into 3, 60, and draw this converted UDL into the point load in a dotted lines. 60 kilonewton. That is very important concept is there. Remember that. Again, next UDL is in between A and B span. Okay, that UDL is how much? 10 kilonewton per meter, and that UDL is act in between the mid span in between AB, that is 1 meter, 1 meter. Is it correct? This is the mid span of AB, and that point load is 10 into 2, 20 kilonewton is acting at a mid span. This 20 kilonewton. This is very important while solving the example. Okay. And all of you know what is step number 1? Step number 1, to calculate reaction. To calculate reaction, that is RA. And RA is a fixed support, RA. Okay. How to calculate? Use the sign convention. Summation f of y is equal to 0. Upward force take it positive, downward force take it negative. Okay, this RA goes to the upward, take it positive, plus RA. Downward force, this 20 minus 20. The next one is minus 30. Why minus? Because this force goes to the downward. Again minus 60, then minus 20 is equal to 0. RA is equal to this minus goes to the left side. All forces is a positive. This 20 plus 30 plus 60 plus 20 is equal to how much? 130 kilonewton. 130 kilonewton. Okay, write down this. R is equal to 130 kilonewton. This is your first step. R is equal to 130 kilonewton. Okay. The next step, to draw SFD. Before drawing the SFD, what the next step? You have to draw the projections. At point D, draw the projections line. Then at point C, draw the next projection line. At point B, draw the projections line. At point A, draw the projection line. Again, question arises in your mind. Why I am not drawing the projections at point these dotted portions? Why? Because I convert that UDL into the point load. In previous example, I already told to you, no need to draw the projections. You convert the UDL into the point load. Okay, remember that concept again. You have to draw the projections. Only the problems given, whatever the loads given in the examples. Okay. Again, you have to use the sign convention. Okay. For that, you have to start from right to left. Right to left. Right to left. What is the sign convention? Downward, take it positive. Upward, take it negative. Okay. And this is your baseline. Above the baseline, you have to draw the positive shear force. Below the baselines, you have to draw the negative shear force. Okay. The shear force. Okay. Shear force at point D. Okay. See, shear force at point D. Concept is what? Force is downward, take it positive. Force is upward, take it negative. And shear force means what? It is an algebraic sum of unbalanced vertical forces, either left sides or either right side. This is the concept of a shear force. Okay. Then shear force at point D. Shear force at point D. Okay. See the sign convention. This goes to the downward. Take it plus. Magnitude is 20 kilonewton. Simultaneously, if you are doing the calculations, you have to also draw the SFD. Okay. Shear force at point D, 20 plus 20. This is the D point. 0, 1, 2, 3 up to the 20. You can take approximately 20 kilonewton. Point load, then draw the positive line. This. Why positive? This is the plus sign above the baseline. Okay. Clear? The next one. Next point is C. Don't consider this point. I am not writing any points at a load 60 kilonewton. Next point is what? C. But remember, your IMP, very important. Listen carefully. At point C, there are two shear forces. Why two? In the first algebraic sum from D to C, first UDL is acting at the point C. Listen carefully. While calculating the shear force at point C, first UDL is acting and then point load is acting at the point C. Okay? At point C. What you are writing here at point C? Due to the UDL. Due to UDL is equal to. Shear force means what? Algebraic sum. Previous is plus 20. Algebraic sum. Previous is plus 20. Then due to the UDL is converted into point load is how much? 60 kilonewton. And this 60 kilonewton goes to the downward. Take it positive. Plus 60. is equal to 20 plus 60 is plus 80 kilonewton, and this plus 80 kilonewton force is acting at the point C, but this is due to the UDL. In between span D and C there is a UDL. Then you have to draw the inclined line. For that, first you have to locate the point or force 80. Okay, 0, 10, 20, 30, 40, 50, 60, 80. Okay. Zero, 10, 20, 30, 40. This is the 80 kilonewton. At the point C, 80 kilonewton force, and then join these two inclined stretches. Why inclined? Because in between C and D there is a UDL. Okay. The next, again, shear force at point C due to point load. Due to the point load. Again, shear force means what? Algebraic sum of previous plus 80 kilo. Don't forget to take the algebraic sum of plus 80. Then another point load is at point C 30. You have to take 30 goes to the downward. Downward means plus 30. Plus 30 is equal to 80 plus 30 plus 110 kilonewton. 110 kilonewton. This 80 at point C, 0, 10, 20, 30, 40, 60, 80. Then 100 and 110. Again draw here, write down here 110 kilonewton at the point C. At the point C. Okay, this is very important. At the point C, there are two shear force. First due to the UDL and second due to the point load. Remember that concept, that is very important. Okay, the next one. Next point is shear force at point B. Shear force at point B. Again, it is an algebraic sum of previous is plus 110. Okay, and at point B there is a no any point load is there. There is a no any point load is there. Means shear force at point B is how much? 110 kilonewton. And in between C and B there is a no any load. Then you have to draw the horizontal line with the same magnitude, 110 kilonewton force. Okay, this is your D point, this is your C point, this is your B point. Shear force at point B is 110 kilonewton. Why I am not adding any force? Why? Because at the point B there is a no load is acting. Next one, shear force at point A. What is the concept? It is an algebraic sum of previous is plus 110 kilonewtons. In between B and A, okay, there is a UDL. And you people convert that UDL into the point load. What is that UDL convert into the point load is 20. And this again 20 goes to the downward. Downward means take it positive, plus 20. Means 110 plus 20 is plus 130 kilonewton. Shear force at point A is 130. Now how to check these reactions? Again 130 means our shear force diagram is correct. Means at point A force is 130. This again at point A 0, 10, 20, 30. This is 110. That 110 above the 130 kilonewtons. This is your vertical line, and this due to the UDL you have to draw the inclined line or join these 2 points. automatically you got the inclined straight line, and this is your positive shear force diagram, SFD in kilonewton. Why kilonewton? Because all forces are given in the kilonewton. Okay, again remember this or check it. Okay, this point load is there, then this is a vertical line, our problem is correct. This UDL is there, then inclined straight line, again correct. This point load is there, this is vertical line, again correct. This UDL, then this inclined line. This is the concept to draw the SFD. Okay. Step number third. To draw BMD, bending moment diagram. Okay. For that, what is sign convention? Upward force, take it positive. Downward force, take it negative. BM means what? Force into perpendicular distance. Force into perpendicular distance. Okay. Again, draw the baseline. Above the baseline, bending moment is positive. Below the baseline, bending moment is negative. Okay. This concept already clear. Okay. Before drawing the bending moment diagram of a cantilever beam, you have to start each and every time at a frame. Remember that concept. You have to always start from the frame. Okay. Then bending moment about the point D is equal to 0. Why 0? Why 0? Because free end. At the point D, bending moment is 0. So many students are writing bending moment at point D is equal to 20. That some students are doing the same mistake. D is equal to bending moment is equal to 20. But 20, our concept is what? Force into perpendicular distance. Okay. That 20 kilonewton is passing the same point at D. There is no distance at the point D. Distance is 0. Means 20 into 0. Again it is a 0. Don't take bending moment at the point D is equal to 20. Remember that. Okay. Clear the concept. If cantilever beam is there, the bending moment at free end is 0. If force is available or not available. Okay. The next point is what? See, bending moment at point C. Again, concept is what? You have to start from the free end. You have to start from the free end. Moment means, bending moment means what? Force into perpendicular distance. Then start from the free end. Okay, and concentrate on a point C. Consider this span only, C and D. Okay, start from free end 20. This 20 goes to the downward. Downward means minus 20. This is the force. And perpendicular distance is how much up to the C? Why up to the C? Because we are finding the bending moment about the C point. This minus 20 into 3. Okay, this is the force and this is the perpendicular distance. Okay, the next point load is what? 60. This again goes to the downward. Minus 60 into this force into perpendicular distance is how much? 1.5. Then minus 150 kilonewton meter. Do the calculations. Ultimately got the answer minus 150 kilonewton. Okay. Then draw the BMD at points D 0. Correct. At the point C. Okay. Next don't consider this 30 again. Why? This 30 kilonewton force is passing to the C point, means there is a no perpendicular distance. Again that force 30 into 0, you got the 0 answer. Don't consider the 30 kilonewton at the C point. Okay? If you are considering, ultimately you got the 0 answer. Okay? Remember that. 0. Then draw this at point C. Our answer is minus 1.50. Minus means below the baseline. 0, 10, 20, 50, 150. This is 150 kilonewton meter. I am not writing the minus sign. Why? Below the baseline, itself it indicates the negative. Then you have to draw here 0, this point, T2, this point. You have to draw the inclined straight line? No. Why? Because in between D and C there is a UDL. If UDL is there, then you have to draw the parabolic curve. Correct. This is the parabolic curve. Correct. The next point. Moment about point C is over, B is over. Moment about point C is over. Then next point is B. Next point is B. Consider again. Start from the free to up to the point B. Moment about point B. Again start from frame. Minus. Why minus? Below, sorry, downward, minus 20. This is the force, and perpendicular distance is up to the B. This force, this minus force, and perpendicular distance how much? 3 plus 2, 5. Minus 20 into the 5. Clear? Next force is 60. Minus, why minus? Because again it goes to the downward. Minus 60 into the perpendicular distance is 2 plus 1.5 is 3.5. The next force, this point load you have to consider. Why? Because there is a distance in between B and C. This again minus. Minus 30 into perpendicular distance is how much? 2 into 2, and your answer is minus 20 into 5, minus 60 into 3.5, minus 30 into 2, and your answer is minus 370 kilonewton meter. Do the calculations. Ultimately got the minus 370 kilonewton meter. Okay. In between B and C there is a node at the point. This is your C point, this is your B point. At the point 0, 100, 200, 300, you can take here 370 kilonewton meter. Join this point in a straight line. Why in a straight line? Because in between C and B there is a no point load. Draw inclined straight line. Clear? Okay. The last point, bending moment at the point A. Again, you have to start from the frame. Okay. Moment about point A. Moment means force into perpendicular distance. Let's start. This is the point A. This is your force. Force is 20. Consider plus or minus? Minus. Why minus? Because it goes to the downward. Okay. This force into perpendicular distance above the point minus 20 into distance 3 plus 2 5, 5 plus 2 7. Clear? Force into perpendicular distance. Next force, this is concentrated at the point A, minus 60. Minus 60 into, again perpendicular distance, 1.5 plus 2 means 5.5. Again next force, minus 30 minus 30 into perpendicular distance about A point. Remember, force into perpendicular distance about A point. Force perpendicular distance about A point. What A? Because we are finding the moment about point A. This minus 30 into distance 4. The next force is there. At B there is no force, but in between A and B span there is one force is there. Minus 20. Minus 20 into 1 meter. You do the calculations. Minus 20 into 7, minus 16 into 5.5, minus 30 into 4, minus 20 into 1. You got the minus 610 kilonewton meter. Why kilonewton meter? Because bending moment is in what? Bending moment means what? Force into perpendicular distance. Force is in a kilonewton and distance is in a meter. Clear? Again, this is your A. 0, 100, 370. Last one our answer is 610. Then take it below. 610 kilonewton. This is the 610 kilonewton. A and B there is a UDL. Then again you have to draw the parabolic curve. This is a parabolic curve. This is your straight line. Again this is a parabolic curve. Okay, and this is your negative BMD, and this bending moment is in kilonewton meter. Okay, in this way we learn to draw SFD and BMD of a cantilever beam with point load as well as a uniformly distributed load. I hope all of you understood the concept. Thank you.